Students and friends, now I am going to discuss here only support reactions of the problem. If any inclined force, either downward or upward force, how to find the support reactions. And one side is hinge support, one side is roller support. Generally, like this questions is coming in the competitive exam. So already you know hinge support having two reaction, vertical and horizontal. Roller support having only vertical reaction, that we should know. So here hinge support. Hinge support we have two, R A V, and one horizontal force I am taking, R A H. So two reactions force will be there in the hinge support, and roller support only one reaction vertical force RB. So how to find this? So what we have to do now, before drawing this we have to resolve these two inclined forces. So we'll draw one more load diagrams here. So we'll draw here one more load diagram. In between we will represent the horizontal and vertical forces for the inclined force, because inclined force having two component, horizontal and vertical, but each force having two component, see here, cos component and sine. Suppose horizontal force FH, here theta is equal to 0 degree. So cos 0 1 sine, but horizontal force vertical component will be 0. If vertical force will be there, theta will be 90 degree. Then sine theta and cos theta, sine 91. So vertical forces horizontal component will be 0. But once inclined force will be there, either this way or this way. Inclined force means theta belongs to more than 0, theta more than 0, and theta less than 90. That is called inclined force. If theta will be 0 degree, horizontal force. If theta will be 90 degree, vertical force. If theta would be in between the 0 and 90, it will be inclined force. Then they are both component will exist, sine and cos. Because you know sine 0 degree 0, cos 0 degree 1. Sine 90 1, cos 90 0. So that means sine and cos value belongs to 0 to 1. So once 0 horizontal, once 90 vertical, between angle 0 to 90 it will inclined load. So now how to resolve this? Inclined force, suppose this is the angle they given how much? Like another direction. No, so this you see here. They given 30. How to resolve? So what will resolve? This is given 40. Resolve now first anywhere in this line you draw one horizontal line with respect to this and perpendicular line this. So this angle equal to 30, this angle also will be 30. So this will come what is 40 cos 30. This will come 40 sin 30. Suppose now this one like this will be there. Like this will be there. So first we'll draw direction is like this. So draw the horizontal line with respect to this horizontal. So this angle this much, this angle will be 25, this also 25. Then mutually perpendicular line is vertical component. So what will be this one then? 30 cos 25 degree. This is 30 sin 25 degree. This way we can resolve this. And we'll write the horizontal and vertical forces. Then we'll find the support reaction. So here see, one vertical force will come. This already vertical given. Here also vertical force will come. So here vertical it will come upward force, because directions will be like this. Here will come like this. Here will come RB. So this is the 20 given already, 20 kilonewton. Now these two we have to calculate. So how much value will come, we will see here. So you see here, now 40 cos 30, 40 cos 30 is coming 34.64 kilonewton. If you'll see we'll remove these things now. So now 40 sine 30 coming 20 kilonewton. 20 kilonewton. So this will be the 20 kilonewton and this will be the directions. This how much? 34.64 kilonewton. So this we know now. Now this will be here 30 cos 25. 30 cos 25 will come 27.19 kilonewton and 30 sine 25 it will come 12.68. 12.68. So this directions will be here how much? 27.19 kilonewton and this vertical force coming how much? This will be downward not 12.68 kilonewton. So this way we know all the forces at point C, at point D, at point E, at point B. Now here at point A will be RAV. This we have to find out here. RAH. So this all we have to calculate. So this way, suppose inclined is there na, see, downward force. Draw this directions, horizontal line with respect to horizontal and mutually perpendicular. This angle should be 90 degree. So vertical component. Similarly, going this direction. So draw the horizontal line with respect to horizontal. Mutually perpendicular, vertical. So this angle 30, this angle 30. This will be the 40 cos 30. This is 40 sin 30. Similarly here, horizontal line. Near angle always will take cos component. Near angle always will take the cos component. Far angle will take sin component. Okay. So this way we know all the value. Now we'll find the support reaction. So sigma FH equal to 0. That means total horizontal force equal to 0. So that means total having in the same direction. So having in the same direction. So what we'll write here? RAH plus 27.19 plus 30.64. Because these directions I taken. But we don't know this directions is correct or not. We'll see if negative coming na, change the directions we'll write. So this and this 3 horizontal force will be there equal to 0. So now RAH will get negative minus 61.83 kilonewton. So what is negative sign indicates here? Negative sign indicate direction is opposite. So RAH direction should opposite. So directions of the opposite. So it is coming minus 61.83. So directions will opposite. Should not change, but you will write here negative sign indicates the directions will be opposite. Now we'll go the sigma FB. Okay, this should be there. Now sigma FB, you see here, sigma FB equal to 0. That means total upward force equal to total downward force. What is? RAV plus RB is equal to downward force how much? Okay, one more upward force is there, plus 20 is equal to 12.68 plus 20, 6.2820. So RAV plus RB is equal to 12.68. Equations number 1. Now we'll take the moment. These things I have rubbed it. So we got the RAV plus RB equal to this much, 12.68. Now we'll take the moment about A. Taking moment about A equal to 0. So moment about A, na, these two force will get 0. Clockwise, moment clockwise, this distance is 2. This distance is also 2. This distance is 3. this distance is 2. All are in meter. All are in meter. Okay, so 12.68 into 2 plus 20 into 2 to 4, 20 into 4, clockwise, anti-clockwise, minus or total clockwise is equal to total anti-clockwise. So, okay, so 20 into taking A. So 3 plus 2, 5 plus 2, 7. Again plus RB into 2 plus 2, 4, 4 plus 3, 7 plus 2, 9. So total distance is 9. 9. So here RB will get. Here RB will get. How much RB will get? RB into, this is distance is 2 to 4. 4 plus 5, 9. 4 plus 5 equal to 9. So, okay, so this we have to calculate. 12 into 6, 8 into this coming 120 bar base punches. So 125.358 is equal to 140 plus 9 RB. So now we'll calculate 125 minus 358 minus 140. So this how much coming? Negative is coming. So we'll check it how much coming. 125.358 minus 140 is coming minus 14.64 is equal to 9 RB. So RB is equal to minus 14.64 divided by 9. So divide by 9, how much coming? 1.63. 1.63 kilonewton. So RB is coming 1.63 kilonewton. If we will substitute in equations 1, RAB will come 12.68 minus 1.63. This is coming negative, no? So it will come plus. So it is coming how much? 12.68. 12.68 plus 1.63 is coming 14.31. 14.31 kilonewton. So this way we can calculate the RA and RB. So RB is coming downward directions. Now what we have to change here? RB, before we taken the RB is positive. Now RB is coming negative. So here directions will be negative. So negative sign indicates, here also write, negative sign indicates RB is in reverse directions. So this like questions, no, the competitive exam they are asking what is the reactions at the B, what is the reactions at RA, and like this what is the force in the point E, like this objective questions they are asking. So RA and RB. So this way we can calculate the support reactions only. Find the support is inclined force will be there. First you convert into two component, then find the horizontal force, find the vertical force here, and find the what is the vertical force at point A, vertical force at point B. So here negative sign once coming, the directions will be opposite. So this way beam is in static conditions. Okay, students, watch the video, share this video your friends. Thank you.